Here are the solutions to your quiz on logs and exponentials. For the first question, both of the bases are related to base 2, so we can rewrite 4 as 2 squared, and we can rewrite 8 as 2 cubed. Then expanding the exponents, we get 2 to the power of 2x squared minus 4x equals 2 to the power of 3 minus 3x. So if the bases are the same, then the exponents must be the same. 2x squared minus 4x must be 3 minus 3x. Making everything equal to 0 on one side, we get 2 minus x minus 3 equals 0, and factoring. Looking for two numbers that multiply to 2, and then two numbers that multiply to 3 for the back of the brackets. And I want my middle term to be negative, so the larger of those two has to be negative. So there's two possible answers. X is negative 1, or x is 3 over 2. To solve the log equation, I need to combine the logarithms. So I can use the quotient law and rewrite this as x plus 5 divided by x minus 3 inside of one logarithm. Now to move this log over to the other side of the equation, I can make it a base of an exponent. So the base 3 becomes the base of the exponent on the other side. So I get x plus 5 over x minus 3 is 3 squared. So x plus 5 over x minus 3 is 9. And now if I multiply the denominator onto the other side, x plus 5 is 9x minus 27. And combining my x terms, I get 8x equals 32. So x is 4. And I can check my answer to see that it makes sense. Log base 3 of 9 is 2. Log base 3 of 1 is 0. 2 minus 0 is 2. It makes sense. To rewrite this equation in exponential form, the base of the logarithm becomes the base of an exponent on the other side of the equation. So lambda equals k to the power of m. To determine an expression for log x, I can take log on both sides of the equation and then use the log laws. The cube root of a is the same as a to the power of 1/3. And if I have division, I can write that as subtraction of two separate logs. The power on the a can become a coefficient. And here I can turn this multiplication into addition. Before I bring the 2 down, because the 2 is only an exponent for the c. So now I can put this negative sign into the brackets, and I get 1/3 log A minus log B minus 2 log C, which which is C. In general, anything that's in the denominator is going to be negative. Any terms in the numerator will be positive. Solving question number 5, I can use base 3, because 1/9 is 3 to the negative 2, and 27 is 3 to the power of 3. Just like I did in question 1, I can then combine the exponents using exponent loss. So 2 times 2x minus 1 is the same as 3 times 2 minus x. Negative 4x plus 2 is 6 minus 3x. And then moving all the x's to one side, all the numbers to the other, I get x equals negative 4. And then to solve this question algebraically using logarithms, because I have x in the exponent, I need to take log on both sides of the equation. So log of the left side equals log of the right side. I can't multiply the 5 and the 6 together because they have different exponents. But I can use the power law to make this exponent into a coefficient. Unfortunately, I can't quite use the power law for this exponent because I have two separate bases. The x plus 1 is only an exponent for the 6. So first I need to separate the two different bases, base 5 and base 6. And now I can take that exponent and make it a coefficient. And if you wanted to, at this point, you could change all your log 4, log 5, log 6 into decimals. And basically, we're solving this just like we would in grade 9, expanding the brackets and then putting all the x's on one side. So x log 4 minus log 4 equals log 5 plus x log 6 plus log 6. So now collect all the x's on one side. I'll move this term over to the left, and I'll move this term over to the right. So I have x log 4 minus x log 6 equals log 5 plus log 6 plus log 4. Now I can factor the x. It's a common factor on both terms on the left, and in brackets I'll write what's left over, log 4 minus log 6. And then on the right hand side I have log 4 plus log 5 plus log 6. So now I can simply divide both sides by whatever's multiplying by log. To come up with a solution. And you can leave your answer in that form, or you can type that into your graphing calculator. If you simplify this, 4 times 5 times 6 is 120. So you could use your log laws to make this even simpler. And this would be the same as a change of base. 4 over 6 is the same as 2 over 3. So that would be the very simplest form of your answer. To solve this problem, I can use the fact that log base 3 of 9 equals 2, because 3 squared equals 9. Log base 4 of 1 over 4 is negative 1, because 4 to the power of negative 1 is 1/4. So log base 5 of x equals 1. So to move that logarithm to the other side of the equation, I make it the base, and it pushes the 1 up into the exponent. x is 5 to the power of 1. X is simply 5. To simplify number 7, because I have two different bases for the logarithm, I'm going to use a change of base. So this is the same as log x over log 27. And log base 9 of x is the same as log x over log 9. I know that 9 and 27 are both powers of 3. So I'm going to rewrite 27 as 3 to the power of 3. And I'll write 9 as 3 squared. Now I can use the power law to make the exponents into coefficients. So this is the same as 9 log x over 3 log 3 minus 4 log x over 2 log 3. Now 9 divided by 3 is 3. And 4 divided by 2 is 2. So I have 3 log x over log 3 minus 2 log x over log 3. 3 minus 2 is 1. 1 log x over log 3. Also known as log base 3 of x. And for the last question, I have a log inside of a log. So to move the log to the other side of the equation, it becomes the base, and it pushes the negative 1 up into the exponent. 1 over 3 to the power of negative 1 is 3 over 1. Anything to the power of negative 1 just inverts the fraction. So now I can move the log base 2 to the other side by making it the base, pushing 3 over 1 up into the exponent. So x is 2 to the power of 3, 2 times 2 times 2, which is 8.